Alright, Ramblers, let's get rambling. We have to prove that FH and JH are congruent, FH being this little line segment right here, and JH being this little line segment right here. So you should probably take an opportunity to code what this is actually asking you to do, which is the toughest part in proofs. I mean, like, you really have to understand a lot about what you're trying to do before you can do it, especially in the case of this proof. What I mean is, I can't prove FH and JH are congruent directly. There's not even like a right triangle we can use. Hinge theorem's not in play because we don't know what these kind of distances are. So it's almost like we have to prove it indirectly. So the question that should be in the back of your mind is, well, what do I have to show in order for these two side lengths to be congruent? And the answer to that question is the triangles that contain those side lengths. So if I can show that this green triangle is indeed congruent to this yellow triangle, then I would argue that these side lengths have to be congruent as a result, because if two triangles are congruent, then all corresponding sides and angles of those triangles are likewise congruent. So that's what we really have to do. We're going to prove the yellow triangle is congruent to the green triangle, and then we'll then be able to state that FH and JH, the two things we're trying to prove, are congruent as a result. So let's take a step back. Well, how are we going to prove the upper and lower triangles are indeed congruent? We're told that information off the bat. Like, we're told that we have a side length here that's congruent in each, and we have an angle that's congruent in each. So if we're thinking about the conditions that do work to prove triangle congruency, we have SA. So all we have to do is just kind of fill in the other pieces. So we have SA. Well, I could go SAS, but if I had SAS, it means I need HG and GI because the ordering does matter here. So that's kind of out. In fact, I'm going to throw side out for the same reason, because we don't have information about sides. So we need another angle. So we need either another angle that flanks the side, being the angle here at F and J, or we need an angle that comes after this angle, which would be the one I have marked 3 and 4. Well, hopefully looking at 3 and 4 and it's becoming automatic. These are a vertical pair, so that's the route we're going to go. We're going to show that these are vertical. That will give a side angle in both triangles, and thus our side lengths are going to be congruent. Alright, let's get to it. While I'm kind of readjusting my diagram, please note that I did change my diagram slightly. I did number my angles, and this makes it easier to communicate versus using like the traditional 3-letter naming convention. I numbered them just so when I say angle 2 and 1, it's a little bit easier than saying angle JIH, HGF, FDJ, JDE. So like numbering, and you guys have caught on to this, actually makes your job a whole lot easier. Okay, so what we're really trying to do here is prove that triangle FGH is congruent to triangle JIH. Because if we can do that, then the side length we really want are forced to be congruent. Per our plan, you can definitely rewind the video if you need to. We're going to be using angle, side. The first angle, which I'll name, will be angle 3 and angle 4 by the vertical angle theorem. The second set shall be angle 2 is congruent to angle 1, and that's going to be because it's given. And the last side length will be FG and JI, the top and the bottom, which is also given. So I mean, a lot of this is actually given. Since these 3 conditions are true, I can definitely conclude that angle FGH is congruent to triangle FGH is congruent to triangle JHI because of the angle side triangle congruence theorem. And then since those triangles are congruent, FH must be congruent to JH because of the definition of congruent triangles, which states that all corresponding sides or corresponding parts of congruent triangles are congruent. And so if you see the CPCTC, that's all it means. It's an abbreviation to tell you that the corresponding parts of congruent triangles are congruent. I don't actually like CPCTC. I think it's silly. Definition of congruent triangles makes a lot more sense to me. Okay? So I hope this helped. I know it's a really short video, but it's actually a fairly short proof. Remember, you have a test on Monday. Spread the word. Maybe someone forgot. Maybe someone doesn't plan to study till late. Something like this that's definitely going to be on the on your test. Like having to prove triangles congruent and then use that information to prove another thing is going to be very, very useful. And since you're taking some time and watching the videos, a question I would ask you is, what now if the real proof, like what I really asked you to do, was to prove that the yellow triangle is congruent to the green triangle. Would you have enough information now that you've proven this first set to prove yellow and green? I think you might. You have upper and lower sides, you have angles, and I think now you have a two-piece side length here as well. So just saying, something like that might be on your test. Whatever. Thank you guys for watching. If you have additional questions, comments, concerns, post them at Edmodo. I'll be checking it all week. Good luck.